You know, when you first look at the periodic table, it kind of just seems like a random jumble of boxes and letters, right? Well, today we're going to see it for what it truly is, a brilliant city map of all the elements. We're going to take a guided tour of its different neighborhoods, the element families, and each one has its own pretty wild personality. But first, let me ask you something to get us started. Why is it that you can drop a tiny piece of one metal in water and get a massive explosion, while another kind of metal can just sit there for years and do, well, absolutely nothing? It seems totally random, but I promise you, it's not. Believe it or not, the answer to that little mystery is hiding in plain sight, right here in the structure of our map. The periodic table isn't just a list. It's a predictive guide that tells us how elements are going to behave. And we are about to use it to unlock some of their biggest secrets. All right, so let's get into it. Let's start with the table's biggest family secret. This is the one thing that makes this entire map work. See those vertical columns? Those are called groups. And really, the best way to think about them is like families. Now, the elements in each family might look totally different. Some are shiny metals, others are invisible gases, but chemically, they act in remarkably similar ways. So, what is the secret? What's the glue that holds these families together? It all comes down to something called valence electrons. These are just the electrons in the outermost layer of an atom. Think of them like an atom's hands. They're what it uses to reach out and interact with other atoms. And here's the key. Elements in the same family have the same number of hands, which is why they behave so similarly. Okay, now that we have that secret in our back pocket, let's start our tour. We're going to head over to the far left side of the table, which is home to the most reactive, most extroverted elements of them all. First stop, Group 1. It's way over there on the, let's call it the western edge of our map. This is the neighborhood of the alkaline metals. And wow, this family, they really know how to make an entrance. The number one thing you got to know about this family is that they are extremely reactive. I mean, so desperate to react that you'll never find them just hanging out by themselves in nature. They're always attached to something else. They're soft enough to cut with a butter knife, and they tarnish instantly in the air. And right there, that answers our big question from the beginning. If you drop an alkali metal like potassium into water, it reacts so violently it actually rips hydrogen out of the water molecules. This creates a flammable gas that immediately catches fire. It's a full-on explosion, all because that little atom is so desperate to give away its one and only valence electron. Okay, moving just one door down, we're in Group 2. Here we've got their slightly calmer cousins, the alkaline earth metals. They're still living in the reactive part of town, but they're just a little less intense. So if you compare them to their neighbors, the alkaline earth metals are definitely a step down in the whole reactivity department. They're harder, they have higher melting points, and instead of one, they have two valence electrons they're looking to give away. When they lose those two negative electrons, they form what's called a 2+ ion. You want a perfect example? Think magnesium. You know in old-timey movies when they take a picture and there's that huge, blinding flash? That was a burning strip of magnesium. It's a really powerful reaction for sure, but a lot more controlled than its explosive neighbors back in Group 1. All right, let's leave the wild reactive suburbs and head into the bustling downtown of our elemental city. This big block right here in the middle, from Groups 3 all the way to 12, this is home to the transition metals. I'm talking about the real workhorses that build our modern world: iron, copper, gold, titanium, you name it. Right off the bat, these guys are way harder and have much higher melting points than the elements we just met. They're also super flexible, chemically speaking. They can form ions with different charges, which makes them incredibly useful. Some of them, like gold and platinum, are so stable you can find them as pure nuggets just sitting in the ground. But you know my favorite thing about them? They're colorful. Seriously. While the metals on the far left make these kind of boring white compounds, the transition metals create compounds that look like a painter's palette. From the green of chromium to the deep blue of copper sulfate, color is a dead giveaway you're dealing with a transition metal. Okay, time for a big jump. We're going all the way across the city to the far east side. If the alkali metals are the most reactive metals, well, this next group is their nonmetal twin. And here we are, Group 17. Welcome to halogen territory. This family has some famous members you've probably heard of, like fluorine, chlorine, and iodine. And just like the alkali metals, their whole story is about intense reactivity. So here's the deal. Remember how the alkali metals were desperate to give away one electron? Well, the halogens are just as desperate to take one to complete their outer shell. That's what makes them so reactive. The name halogen actually means salt former, and it's because when one of these meets a metal like sodium, bam, they form a salt. You know, like sodium chloride, plain old table salt.
So we've seen the explosive extroverts and the intense reaction seekers. For our last main stop, we're visiting the most exclusive, reserved, you might even say unbothered family on the entire map.
Welcome to the VIP section, way over on the far, far right edge, Group 18, the noble gases. We're talking about helium, neon, argon. They're the true aristocrats of the periodic table. They just keep to themselves. They almost never, ever interact with the other elements. So, why are they so standoffish? Well, it all goes back to that family secret, those valence electrons. The noble gases have a full outer shell. They're totally content. They don't need to give, take, or share any electrons, which makes them perfectly stable and, chemically inert. They're happy just the way they are. And this, right here, just perfectly captures the incredible range of personalities we've seen. We started with the violent, chaotic explosion of a metal in water, and we end here with the calm, steady, beautiful glow of a noble gas like neon when you pass an electric current through it. So there you have it. In just a few minutes, we've met some of the table's biggest families. But honestly, our tour just scratched the surface. We didn't even really stop in Group 16, which is home to the oxygen we're breathing right now. Or Group 15, which has nitrogen, a total cornerstone of life itself. See, the periodic table isn't just some confusing chart. It's a logical, predictable map of how things work. And that just makes you wonder, what other secrets are these elements still holding?